We are going to introduce a new concept that's row echelon form, and reduced row echelon form is equivalent to row echelon form is equivalent to the Gauss elimination method, and reduced row echelon form is equivalent to the Gauss-Jordan method. So I can show you how. We are having here always the starting value is 1. As 1, we say it is leading entry. We call this one as leading entry. So in the second row, when the leading entry is coming, this is on the right of the above one, always. This again is coming on the right of the above one, always. So we say these are leading entries coming on the right in each row, and then we have below the leading entry, the values are 0. So we say this is row echelon form. So you can see that in this matrix 2, we have the leading entry 1, next leading entry on the right, next, and here it is 0. So we say when there's 0 row, that's coming in the bottom. We'll group this one in the bottom, interchange and bring the bottom. This is our row echelon form. Again, we can see it here that this value is starting from 0, but any of the row is starting from leading entry 1. If 0, that's coming on the left, but the starting value is 1, like this one. So here, the first non-zero value will be 1. Then the next leading entry is coming on the right. Next leading coming in is mean is row echelon form. So there are only 3 leading entries in 3 equations, but here they are going to obey the rule that the leading entries come on the right. There is no 0 line, so there is no problem. If this was 0 line, that's coming in the bottom. So we say this one has reduced row echelon form, and this a form. But here there must be 1. As I told you, in case of Gauss-Jordan method, it may not be 1. But when we say row echelon form, it must be 1. When we say solve by row echelon form, that means the starting value must be 1. Come to the next one. We say reduced row echelon form. In reduced row echelon form, again, each row is starting from the leading entry, and this next leading entry is coming on the right, just before, like the row echelon form. What's the difference? The difference is here, in the leading entry, in the column, the other values were 0. Here you can see this leading entry, but these values are 0. This leading entry, but these values. But here, in this case, reduced row echelon form, in the leading entry, all the values must be 0, except this leading entry. So this is 0, this is 0. This leading entry, these values are 0. So this addition to that one, in reduced row echelon form, when we have the leading entry in a column, all other values must be equal to 0. The third thing, if there's 0 rows, they are coming in the bottom. 0 rows coming in the bottom. You can see, especially we check this one. This is a leading entry, all the values are 0. The next leading entry is here. All the values are 0. So we say this one is the reduced row echelon form. I write here matrix A, and we see, you can hear this matrix A. I'm having here 1, 0, 0, 0. This is 2, 3, 4, 5. This here is 0, 1, 2, 1. This here is 0, 0, 0, 1. And this here is 0, 0, 0, 0. We can see it here. What is this? This is my row echelon form. Why? Because here we have leading entry, and the value is not 0 in this whole column. But here it obeys the rules of the row echelon form. Leading entry, next leading entry on the right, next leading entry on the right. I write here a matrix B. And in the matrix B, I have here 1, 2, 3, 0, 5. I get here 0, 0, 0, 1, 2. I have here 0, 0, 0, 0, 1. I am having here 0, 0, 0, 0, and 0. Now I check this matrix. In this matrix, we're having here the leading entry is over 1. The next leading entry is coming on the right, next leading entry coming on the right. Now, in this case, we want to check is row echelon form or reduced row echelon form. Now here 1, all values are 0. Here's 1, all values are 0. Here 1, the values are not 0. So this is not reduced row echelon form. We want to make reduced row echelon form. That means these 2 values that must also become 0. Now this become reduced row echelon form. The main difference is the leading entries, each row is starting from leading entry, next leading entry is coming on the right, 0 rows coming on the bottom. If in the leading entry contain all the values 0, then it's reduced row echelon form. If all the values are not 0, like this one, that's the row echelon form. So when we say that we are using row echelon form, this means we are having here Gaussian elimination method. So, and when we say reduced Echelon form, we say it's Gauss-Jordan method. So they are equivalent. We say the Gauss-Jordan method, or we say reduced Echelon form. We're having the same idea. So next, when we are going to discuss, we say we solve the system by using row echelon form or reduced row echelon. So we are just going to solve the system of linear equations. And this system will have many solutions. We know it before. So we are using the reduced row echelon form to solve this one. So I have written the argument matrix. As I told you that we always start from the argument matrix. So we write our data. This is 1, -1, 2, -1, and 1. I have 2, 1, -2, 2, and -2. I have -1, 2, -4, 1, and 1. Then get here 3, 0, 0, -3, and -3. Now, next is my strategy to solve it. And to solve this one, what I want to see, reduced row echelon form. So it's starting from 1 is okay. I don't need to make any row operation to bring here 1. So next is, I want to make this one 0, I want to make this one 0, and I want to make this one 0. For this one, we use the row operations. The first row we multiply by -1, minus R1 plus R2. So that makes this one 0. Here we just add R1 and R2. That will make me this value equal to 0. Then the third one is I multiply by -3 R1 plus R3. That will give me the first column, all the column, a value other than the leading entry equal to 0. Now let me write here, and we solve this one. So my first row remains unchanged. It's here 1, -1, 2, -1, and -1. And the next one, I'm going to multiply by -1. Multiply by -1, get here -1, I get here 1, I get -2, I get here 1, I get here 1. This is my row 1, multiply by -1. Then the row 2, I just add it. Oh, sorry, I have to multiply this by -2. So it means here I'll get the values as -2, 2, -4, 2, and 2. Now my second row is 2, 1, -2, -2, -2. We add it, we get here 0, we get here 3, we get here -6, I get here 0, I get here 0. So I can write the new row here. This is 0, 3, -6, 0, and 0. Now my second row operation is adding row 1 and row 3. I get here 0, -1 and 2, we get here 1, 2 and -4, we get -2, -1 plus 1 is 0, -1 plus 1 is 0. So this is my new R3. For the last row, row 4, I just multiply, this one is R3, and this one is R4. I just multiply first row by -3 and add to row 4. So multiply -3, I get here -3, I get here 3, I get -6, I get here 3 and 3. My R4 is, the values are 3, 0, 0, -3, and -3. We add it, I get here 0, I get here 3, I get to -6, I get here 0, I get here 0. So I can write this one as 0, 3, -6, 0, and 0. So in my reduced row echelon form, I must get my leading entry, the second leading entry here. So I can do it by different way. One, I can do it, I multiply this one by 1 by 3 and get the new row. So I just multiply here this by 1 by 3. I'll get here 0, 0, 1, -2, and 0. I just replace this row by multiply 1 by 3. This one, the operation I'm going to do here. I multiply here by 1 by 3, R2. My new row become here 0. I get here 1, I get -2, I get here 0, and 0. I make the row operation, and now my next step is, this is my leading entry. I want to make this one 0, I want to make this one 0, I want to make this one 0. Very simple. Add these two, add these two, add these two, we get here 0. Multiply -1, add to this one. This here is R1 plus R2. Then this is minus R2 plus R3. Then here -3 R2 plus R4. So let us see what we're going to get it. When I make this row operations, then I'm going to get here, this is my 3 rows. Equivalence, I make it. My row 2 is not changing, this 0. 1, minus 2, 0, and 0. This is not changing. All other rows will be changing. So I'm going to get here, adding this 2, get here 1. We get here 0. We get here 0. We get here minus 1. And we get here minus 1. Now multiply minus 1 add to this one, we get here 0. Multiply minus 1 add to this one, we get here 0. Multiply minus 1, this is 2, minus 2, this will be 0. We're having 0, we're having here 0. Multiply minus 3. It's minus 3 plus 3 will be 0. Then it's plus 6 minus 6 will be 0. This is my 0 and this is my 0. So this is the picture I'm going to get it from this calculations. And this is my reduced Echelon form. We test it. My leading entry 1, next leading entry coming on the right. All the values in this leading entry value is 0. All the entries in this leading entry is 0. 0 rows at the bottom. 0 rows at the bottom. Now I am having very different question, different solution than the last we are going to do. We rewrite the equations. When we rewrite the equations, so my first value is representing x. This is representing y. This is representing z. This is representing w. So I'll get here the first equation. I write here x. Then we're having minus w. And this is equal to minus w is equal to minus 1. This is my first equation. My second equation is, I get here 0. This is my y. I get here y minus 2z equal to 0. These are my two equations, only left. Now I have three variables are my x, y, z, and w. There are 4 variables. Now we are having 2 variables which are coming with x and y, which are coming with 1. This x is coming with 1 and y is coming 1. The variables coming with 1, we say leading variables. So we are having here the variables coming with 1, we say leading variables. So these leading variables are x and y. What about z and w? There is no leading entry here. There is no leading entry here. We call this variable as free variables. They can have any value. The free variables, we have 2 free variables. These free variables are z and w. They can have any value. We say here, we take the value of z equal to t, any real number. And we take value of w is equal to s. I say t and s are my real numbers. They can get any value. Now we rewrite this one. So I get here my x minus s is equal to minus 1. That give me x is equal to s minus 1. Then I have here my y minus 2t is equal to 0. I get here y is equal to 2t. What's my z? My z equal to t. What's my s? My s is equal to, my w is equal to s. And I have here my t and s are any real numbers. Now I just take different values, my to t and s, and get here different solutions. So I just take here to show the solution of this one. I take the value of t equal to z equal to t. And we take t equal to 1, we take any value, s equal to 0. When I take t equal to 1, s equal to 0, I get here x equal to minus 1. I get here y is equal to 2. I get here z equal to 1. And we get here w is equal to 0. So this is my solution. So for each value of t and s, I'll get the solution. So we can have the value of t and s, we can have infinite number of values. We can take t equal to 1, s equal to 2, t equal to minus 1, s equal to minus 2, t is 1 by 2, s is any real number. So we get having many solutions. So we say there are infinite many solutions. Infinitely many solutions. So one more thing we can say, because having infinitely many solutions, so we say the system is consistent. So we can write here, our system is consistent. So one more thing we can say, because when there is no solution, we say system is inconsistent. As many solutions, we say system is consistent and have many solutions as shown. I've just taken, for example, the value of t and s is equal to 0 and 1. I can take any value. I can take t equal to 1, s equal to minus 1. I can take t equal to 2, s equal to 5, and so on. So for each value, we'll have the solution. So we're going to discuss an example where the system will have no solution. So again, we'll use our row reduction method for solving it. So we're having the equations x minus 2y plus z equal minus 2u equal to 1, x plus 3y plus 7z plus 2u equal to 3, x minus 12y minus 11z plus minus 16 equal to 5. As I told you, we always start from the argument matrix form. A is the coefficient, b is our constants. So we write the data here. Now again, our next step is always, that is starting from 1. We want to make this one 0 and this one 0. That's our row reduction. So we keep our first equation as it is. This is 1, minus 2, 1, minus 4, and 1. Next equation we have minus. We can write like this one also, minus r1 plus r2. Multiply minus 1 and add to this one. Multiply minus 1. We get minus 1, we get here 2, we get here minus 1, we get here 4, and we get here minus 1. We multiplied r1 by 1, and then add to this one. This here 1, 3, 7, and then we're having 2 and 2. We add it. We get here 0, we get here 5, we get 6, we get 6, and get here 1. So we can write here our second new row here is 0, 5, we have 6, 6, and 1. The next is to make the elimination for R3 again. We multiply minus 1, add to this one. We multiply minus 1, we get here 1. We get 2, we get here minus 1. We get here 4, we get here 1. My third row is 1, minus 12, minus 11, and we have minus 16, and we have 5. We add it. We get here 0, we get here minus 10, we get here minus 12, we get here minus 12, we get here 4. So I write my new equation. My new equation is 0, minus 10, minus 12, minus 12, and here we get here 4. This is minus r1 plus r3. So my next step is, I'm not looking here, we are not asked that we saw reduced echelon form or row echelon form. So we go on a situation, and according to that one, we try to solve our equations. So we look on situation. The situation is like this. I can just multiply 2, this will be 0. So I want to make this one 0. I multiply this equation by 2 and add to this one. So my next step will be, I'm just going to write it, the first 2 rows, and then make the operation of the second row to bring third equation, new equation. We're having here 1, we get here minus 2, we get here 1, we get here minus 4, and we get here 1. So this is my row 1. My row 2 is 0, 5, 6, 6, and we have 1. So I multiply this row 2 by 2 plus 2 and add to row 3. So when row multiply by this one, we get here 0, we get here 10, we get here 12, get here 12, multiplying by multiplying by 2, so we get here 2. My row 3 is 0, get minus 10, get minus 12, get minus 12, we get here 4. And here we are having the equation, we just add them. We get here 0, 0, 0, 0, and minus 2. So I write it here. I get here 0, 0, 0, 0, and minus 2. We look on the equation, what we are saying, the last equation. We're saying it like this one, 0x plus 0y plus 0z plus 0u is equal to minus 2. What we are saying? We're saying here 0 is equal to minus 2, but we're having here 0 is not equal to minus 2. So the system will have no solution. Because this is not possible, this is not equation, will not have any solution. I will say the system has no solution, and this is system we say is having no solution. We say system is inconsistent. Inconsistent. So we have discussed the examples. And the solution was consistent. In the first 2 examples, there was unique solution. Then I give you the example when having many solution, and then I give you the example there is no solution. When there is one solution or many solutions, the system is consistent, and when the system has no solution, we say system is inconsistent.